We're now going to take a brief look at the concept of midpoints, right? And this is a concept and a formula that you may already know, but just for completeness, I want to make sure that everyone's on the same page. So we're going to look at midpoints in both R2 and R3, and we'll start with R2 and then essentially just extend the idea from 2 to 3 dimensions. So let's say we're in 2 space. So we have our coordinate plane, and suppose we have 2 points. Let's say they're point A, which has coordinates x1, y1, and B, which has coordinates x2, y2. And then, of course, we can define the line segment that goes from A to B, like that, right? And as far as the midpoint is concerned, it is, and I'm just going to estimate it now, but it is essentially the point that is exactly halfway between A and B. So formally, if I call this M for midpoint, the way one way to define the midpoint formally is to say that I'll just use this to represent the distance between or the distance from something or between two objects. So if I say the distance from A to M, then that would have to be equal to the distance from B to M or M to B, whichever way you want to write it, right? The distance function is symmetric in this case, right? So that's the concept of the midpoint, right? So this is our midpoint. So the question is how if I know the coordinates of the endpoint of the line segment, how do I find the coordinates of M? That's essentially what we want. Well, it turns out it's a simple idea. So if you think about it, on the let me label just the x values. So this is x2, this is x1. So if I were to ask you where's the middle, right? How do I find the middle between these, right? Well, that would be the average, right? That's how you find essentially the middle or the midpoint of just two numbers would be the average of those two numbers. So basically this x right here would be x1 plus x2 divided by 2. And then if I did the same thing with the y's, so if, then this is y1 and this is y2. And then if I said, well, what's the middle of these y values, right? Again, you just take the average of them. So then this would be y1 plus y2 divided by 2. But that means the coordinates now of the midpoint of that line segment, it would have an x value that's an average of the two x's, and it would have a y value that's an average of the two y's. So we have this nice formula. So the coordinates of M are given by, so I'll just put M there and then in parentheses. Yeah, so you just take it's the again the average of the endpoints, the x endpoints, and then the y endpoints, and that gives you the midpoint of the line segment, right? So again, just a quick example. I mean, there's really not much, but let's say this: the midpoint of the line segment from 2, -10 to, let's say, 513 is, and this is all you do. Yeah, so you take the average of 2 and 5. Again, you want right in the middle. So you average those two. And then average the y value. So you'll take the negative 10 plus the 13 divided by 2. And then this gives you 7 over 2, comma, and then this would be 3 over 2. And notice the idea of using, again, we're using algebra, which is, again, very basic algebra here, really arithmetic, to solve this geometric problem. So this is not something where we're going to construct it on paper and measure things, precisely. I mean, we can't be that precise in our measurement, right? But using this formula, we can get the precise coordinates of the midpoint, right? So that's what it looks like in R2. And as you might imagine, in R3, what do you think we're going to do? Well, we're going to continue this process of averaging the two endpoints for X, for Y, and then for Z, right? So I'm not even going to draw it. I'm just going to make the statement and then do a couple examples, and that'll be it. So let's say, so in R3, the midpoint of, and let's say here are my 2 points now, so x1, y1, z1, and x2, y2, z2. So the midpoint of, well, I should be a little bit more precise. The midpoint of the line segment between those 2 points is, and here is the formula. So again, I'll call it M for midpoint, and you average the x's. So the average of the x's, the average of the y's, and now the average of the z's. It's so useful, again, and we'll see it several times over. Once we understand a concept in R2, especially the geometric concepts, they extend readily to R3. All right, so let's look at a couple examples of this. So suppose A, let's see, 3, -4, 6, and B, let's say 2, 8, and 10 are endpoints of the diameter of a sphere. Right? Yep. So suppose we have these are the endpoints of the diameter of the sphere, and obviously that means we're in 3 space, and we can see we have our 3 coordinates there. What is the equation of the sphere? So what is the, and let's just go with the standard equation, right? So what is the standard equation of the sphere? Right? Well, in this case, I am going to sketch so we can see exactly what this description is referring to. So we have a sphere. I'm not going to draw like the axes or anything. I'm just going to say we have a sphere, and we know what the diameter is, right? So it's a line connecting 2 points on the surface of the sphere that passes through the center. So the center would be here, and I'm going to draw our diameter. Let's say it's there, right? And then this point here, it doesn't matter which one I label as A and B, but because think about it, I can rotate this thing like a ball. You can rotate it and stuff like that. So I'll just say this is A, which would mean the other point would have to be B. And what we would like to be able to do is to now find an equation that describes all the points, right, on the surface of this sphere, right? Well, what we need to define a sphere, we need two things. We need its center and we need its radius, right? Well, again, because of how the diameter is defined, if I were to compute the midpoint of the line segment AB, that would give me my M, my midpoint, right? So let's write that down. Write a little statement and then do a little calculation. So the center of the sphere, right, is in fact the midpoint of the diameter. And since we have the endpoints of the diameter, not pluralize, just the midpoint, I'll just say of diameter AB. So diameter AB. So let's go ahead and compute the midpoint. So again, I'll continue to use it as, you could say M or you could just say C for center, whatever it is. So let's average the x's. So this is 3 plus 2 divided by 2, negative 4 plus 8 divided by 2, 6 plus 10 divided by 2. So it ends up being this point. So it's 5 halves, 4 halves, which is 2, and then 16 halves, which is 8, right? So I now know where this sphere is centered. So I have one of the two things that I need. The other thing that I need, in fact, let me go ahead and write this in. So this is our 5 halves, 2, and 8, and that's that specific point. The other thing that we need is the radius. So we need that distance, right? So we need our r, right? And there are two ways we can compute the r. We can use the given points that are in the problem, find the diameter, the actual diameter of the sphere, which would be the distance from A to B, and then take a half of it, right? Or we could just take the distance from one of the given points to the center that we just found, right? So what I'm going to do, I'm going to take the distance between the two given points, right? Why am I doing that? Because in general, if you the more work you can do with the information that's given in the question, as opposed to relying on things that we've calculated throughout our solution, the less likely you'll have lots of errors, right? So in other words, what if we messed up, right? What if we messed up with the center, and then we use that incorrect center and we came up with an incorrect radius? Well, you know, that's like a double whammy. So let's find the distance from A to B. So let's do that. So the distance from A to B, or you could say the length of line segment AB, is, and so let's use our distance formula. Let me go back up so you can see the values. So I'm going to say I'll just use D for a generic label for distance, and that's our square root. And what do we take the square root of? Well, we take the difference between each of the coordinates, right? X, Y, and Z, square that difference, then add them together. So it is 3 minus 2 squared plus negative 4 minus 8 squared plus 6 minus 10 squared. And let's see what we have. So 3 minus 2, that's 1. 1 squared is 1, plus, then we have a negative 12 squared is a positive 144. And then here we have a negative 4 squared is a positive 16. So 144 plus 16, that's 160, plus 1 is 161. So the exact distance is the square root of 161. And therefore, the radius of the sphere, so therefore, the radius of the sphere is, yeah, half the diameter, or half this distance. So it's 1/2 of d, which is equal to, and I'll just write it as 161 over 2, right? So now that we have the midpoint and we have a radius, then we can write down the standard equation of the sphere. So I'll remind you of what that is. So using, and let me write that, and so this is the standard equation. You have your x minus the x value of your center squared plus y minus the y value of your center squared plus z minus the z value of your center squared, and that's equal to the radius squared. So using this, the standard equation of the sphere is, right? So with lots of points and lots of numbers, just be clear which one, which ones you're using. So this is your x0, y0, z0, that's your center, and of course this is your r. So when we set it up, we're going to have x minus the x value, which in this case is 5/2. That's going to be squared, plus y minus the y value, which in this case is 2, and then that quantity squared, and then z minus 8 squared, and then I have to square this. But when I square the radius, what happens is the root in the numerator goes away, and this should be an equal sign. So we'll have 161, and then divided by, when we square the denominator, right, we end up with 4. And what we're using right here is the property that a over b squared is a squared over b squared, right? So this is the standard equation of the sphere that satisfies the given properties, right? So really simple formula, but it is really useful in lots of applications. So keep this formula in mind, and I'll see you in the next video.